Good afternoon, and I'd like to welcome you to the third webinar. This one is on decimals, and it's titled, It's Not All About the Point. I am Maria DeLucia from Middlesex County College, and my colleague Frank Gardella from Hunter College is here, and we will be presenting this afternoon. If you have any questions, please type them into the chat box. As we go along, we will answer any questions, or if you'd like to save them for the end, we'll answer any questions that you have. So please feel free to type into the chat box, and we will address any of the questions or concerns that you have. So we'll get started now. Okay, our objective this afternoon is what is the decimal point, understanding the meaning of a decimal as numbers through the development of the base 10 number system, and to focus on the placement of decimal point in calculation and estimation. One of the important things I believe in all of this is the meaning of a decimal as a number and the development and the connection through the base 10 number system. The whole point of building our number system from whole numbers to fractions and decimals is this expansion of our number system, basically patterning it on what we've learned about whole numbers, then fractions, and now decimals. So this is what we hope to accomplish this afternoon, about showing you the development of this number through the base 10 number system. Okay, what is the definition of a decimal point? What is it? We tell the students it's a point. The decimal is a point that separates the whole number from the fractional part. And when you say to them the fractional part, that's a bit confusing because they don't see a fraction. But it's the ability to understand that that is the fractional part. It's part of a number. And one of the things we will show this afternoon, or we hope to show this afternoon, is the ability to go from the fractional part to the decimal part, from the decimal part back to the fractional part. This is the second one is a definition that usually occurs in more advanced math, but it's an important point for us to know that it also indicates the place of value which changes from the positive to the negative powers of 10. That decimal point is the separation. As we go to the left of the decimal point, the powers of the exponential powers of 10 start to increase, 10 to the first, 10 to the second, 10 to the third. As we go to the right, the exponential powers decrease, 10 to the negative 1, 10 to the negative second, and so on. So in the lower grades, they know it as the point that separates the whole numbers from the fractional part. In more advanced math in the upper grades, when they start to talk about the place value system dealing with the exponents, it's where the exponents change from positive to negative. Okay. The Common Core mathematical practices, of which there are 8, make sense of the problem and persevere in solving them, reason abstractly and quantitatively, construct a viable argument and critique the reasoning, and model with mathematics. The modeling with mathematics, I believe, is the most important part, and we will go through that this afternoon on how to model the mathematics so that the students really can find and develop a conceptual understanding of what they are doing. I believe that's one of the important parts. Use appropriate tools strategically, attend to precision, look for and make use of structure, look for and express regularity in repeated reasoning. So those are the 8 mathematical practices. These are the mathematical practices that I believe are really what we should demonstrate or focus on in math, in the teaching of decimals. Make sense of the problems and persevere. Students should be able to apply their understanding of operations with whole numbers and fractions to decimal concepts. Again, it's that building, that ability to build from what they know from whole numbers to fractions to decimal. It's extending our number system. It's building on our number system. So that ability to take all of those concepts and to now extend them. Reason abstractly and quantitatively. Students should consider the decimal place value of how a number represents 10 times as much as the number to the right. Again, it's that 1/10, 1/100. It's that ability to realize that our denominators are decreasing by powers of 10. So you're stating again, as we go to the right, the exponents would be increasing, 10 to the first, then we go 10 to the -1, 10 to the -2nd. So as we move to the right, they're 10 times as. Okay. Construct a viable argument and critique reasoning with others. Students should tell and show how to represent decimals when they change whole quantities. And I think that's an important part when they're changing. And this we will show you later on about how I can change 10/10 to be a whole, to take a whole and change it to tenths. I think it's that, again, building upon what they've learned prior and how we can take it now into the next level. Attend to precision. Students communicate precisely with others when discuss and decide how to represent one whole, 1/10, 1/100, 1/1000 in the same model. Again, when they start looking at decimals, and I know that my students, and I teach at a community college, and I always tell them when they take 0.05 and they change it to a percent, they're always changing it to 50%. Again, it's that place value. What does that 0 represent in that position of 0/10, 5/100? How to change the tens, hundreds, and thousands in the same model. So again, it's that precision, attending to precision. And I think looking for and expressing regularity in repeated reasoning. Students consider whole number place value and how it relates to the decimal place value. Again, it's taking our number system and extending it from what we've learned before in the place value system to extending the place value system to be parts of wholes, 1/10, 1/100, 1/1000. So those, I think, are the important mathematical practices that we should focus on when we look at dealing with and teaching with decimals. Okay, one of the things that I think is important when how we teach is that there is a connection, and this actually is the Lesch model for being able to teach. And Dick Lesch did a lot of research on dealing with ratio and proportion, dealing with fractions, dealing with decimals, and how students think and how students work with these numbers and how they develop a conceptual understanding. And if you see, it's pictures, it's written symbols, it's the spoken language, it's manipulatives, and they're all interconnected. I think, starting with manipulatives, going to the pictures, going to the written symbols. What is the language? Especially the language when you're dealing with decimals. How do we change? How do we change the relevant and irrelevant situations? How do we change that?
And what we're going to do as we proceed through this video now is there's the Lesch model showing that they're all interrelated. What we're going to do is lay out for you a model which is more linear to give you an idea of how the Lesch model can actually be applied in the classroom in students' learning.
Yeah, we've taken this model and we've kind of put it into a little bit condensed form, but it's the basis of that students need to progress in their learning, and they go through stages. They go through these stages, and these stages are, starting out with manipulative, starting out with pictures, taking it to the written symbols, the spoken language, and being able to apply it into the relevant situations. Okay, understanding, these are the Common Core standards. Understand decimal notation for fractions and to be able to compare decimal fractions. So let's look at, here are the decimal blocks, which are similar to the base 10 blocks. And as I stated before, it's looking at your ability to go from what they've learned before, to what they are now taking as an extension. It's the base 10 blocks. We have a hundredths block. Each one of those is based into hundredths, and then we have a tenths block. So if we look at being able to represent 32 hundredths, that's 32 out of 100. So there is the decimal notation. There is the fraction notation. So we have 32 hundredths. So here would be a task that would go with that, asking the students, here's a hundredths block, here's a tenths block. How can I shade these blocks to show that 50 hundredths is the same as 5 tenths, and being able to show the equivalence here and coloring this. So I'm using my base 10 blocks now as decimal blocks and showing them, building upon what they've learned before, how I could use this. And again, this is the picture of what they are doing. So we're taking the picture, the manipulative of being able to represent this in a symbolic form. So here would be, how would I represent 52 hundredths? So I'm just going to extend it a little more, and I would have 52 hundredths. So again, it's using the manipulatives to begin this part of it. So once they've learned how to shade it, now here is a shaded, and asking them from the shaded part, what number does this represent? So again, it's now looking at the picture and being able to tell me the number here. So if we look at this, what number do you think this would be? Well, that is a hundredths block. I have 100 hundredths. So what would that be? That's a 1. And then I have 50 hundredths, so that would be 1 and 50 hundredths, or 1.5. Again, it's now looking at using the representation of my blocks to be able to write my numbers as fractions, as decimals. So I can say that's 100 over 100, which they should know is 1. I have 50 over 100, which is the same as 5 over 10. Being able to convert that, I've got 1.5. 1.5. So these are ways of now using that Lesch model to say I have manipulatives, I have a picture, and I'm going from the manipulative to the picture to the symbolic form.
So what we use here in our work is what we call the M4 model, and it's really four levels of moving through the mathematics. The first level will be the kinesthetic, and that's really the hands-on model, where basically the language is oral. There is no real writing going on. It's just a matter of getting the kids to understand it. Here you would use your decimal blocks, or you could use base 10 blocks, redefined in a sense. The second part of the M4 model is the language model, where we start to incorporate the language, except we use the words. So for example, in working with decimals, instead of have it written out as TENTHS, because we feel that the children need to see the words that we're talking about before they actually start to assume what the words are based on the place value. The third level is the connecting level. That's the third part of the stream, which starts to take the kinesthetic and the language and connect it to the symbolic. And in this case, what we do is we use the kinesthetic and the language, connecting it to the symbolic in a way that the students start to understand how to write these ideas or communicate these ideas with the symbolic, how all of these things come together to create the symbolic. And finally, the last level is obviously what we want to get the children to, is where they can actually use the symbolic to communicate the mathematics that they have learned. What we're going to do now is look at a video where we can see these levels. We're going to use a video that shows a level of going from the kinesthetic pieces and the bricks, as we call them, to the symbols.
Let's look at how we can write a number. the number is going to be 2 4/10. So what we have is, let's record that. We have 2 4/10. Now, if we were writing this as a fraction, we could write the numeral 2 and then the fraction piece, the tenths piece, as 4/10. But since 10 is part of our decimal system, we can write this in a different way. We can write it as 2 4/10. And then write it using the whole number 2, using a period to separate the 2 or the whole numbers from the fractions, and then just write the 4. Because we know that the 4 is going to represent tenths. This is only when we have fractions whose denominator is 10. So we can write it as 2 4/10, as we have done. We can record that as 2 4/10, or we can write it using a period to separate the whole numbers from the tenths, and we can say 2 4/10. And as soon as you see the period, you know that to the left of the period is going to be whole numbers, to the right of the period are going to be fractions. But they are going to be fractions, in this case, where the denominator is 10. But you don't have to put the denominator because we have the period. So we have 2 4/10. And we call the period a decimal point. Decimal coming from the idea that we're in a base 10 system or a decimal system. So 2 4/10 can be written on a screen like 2 4/10. You can write out the words 2 4/10, or you can write it in a mathematical way with 2 decimal 4. But this is read 2 4/10.
Okay. Here's an activity that can show equivalent fractions and leading to equivalent decimals, or which decimal is greater, which decimal is larger, and the equivalence of what 1/2 is as a percent or a decimal. If you graph the fractions as ordered pairs, 1/2, 3/4, where you're saying that the denominator would be halves and fourths, what kind do I have? I have halves, fourths, thirds. The numerator represents how many of the, what part of the fraction I have. So I have here again, as I've graphed it, 1/2 would be the ordered pair 2, 1. 4/3 would be fourth. The denominator is 4, the numerator is 3, so that would be the ordered pair 4, 3. So again, it's graphing this and looking at this, but if we take it a further, the next step, we can look at this and we can see that if I graph 2, 1, 4, 2, 3, 6, I get, if I connect those, you could see that 1/2, 2/4, 3, 6 are all equivalent fractions. They are equivalent. And you can do this with thirds, you can do this with fourths, I can do it with any denominator. But it begins to show them equivalent fractions. And then if I take it to the next step, where I now have, here are my fractions, and here I have a decimal ruler attached to my graph paper. And if I start to connect the fractions, the equivalent fractions, and I extend that line, I can see that the fraction 1/2, the fraction 2/4, the fraction 3/6, and if I extend the line, that's all equivalent to 5/10 or 50%. I can take all of this and I can now show with equivalent fractions, changing it to a decimal, and that will start me to be able to look at which fraction is larger, then which decimal is larger. It's comparing fractions, comparing decimals. This is just an activity, again, for visualization, because what they are asking us to do in the standards is to do things on a number line. This is a graphical number line, which can be used in the 4th grade, 5th grade, and then when you get into the upper grades, you can use this for slope, showing rates of change. So this is an activity that you can extend, and you can, again, make it into more advanced math by extending the concepts as you do with the base 10 blocks and you do with the decimal blocks. It's, again, extending our number system to show that fractions can be changed to decimals, decimals can be changed to fractions. Fractions and decimals are equivalent, just numbers that are written meaning the same thing, but just written in a different form. So with what I just did, if it states that Alex ran 5/10 of a mile, what number should be placed in the question mark to make the fraction equivalent to 5/10? I can go back to my graph and look at, if I look at what 2/5, 5/10 are, they're equivalent, what does that mean? What would go there? Again, also knowing that if I am one place over, that would be to the right of the decimal point. That should be a 5, knowing that 5/10 is equivalent to 5/10. So again, it's that notation of going back and forth from the decimal to the fraction to the decimal. It's being able to go back and forth. Okay. Here is another one of the Common Core standards. Express fractions with denominators 10 as an equivalent fraction with denominators 100. And use the technique to add two fractions with respective denominators, such as 3/10 as 30/100. To add 3/10 and 4/100 would give me 34/100. So here would be an activity, and in this activity you have 43 and 65/100, which I can write as 40 plus 3. Again, think back to when we teach children to take and write our whole numbers in expanded notation. This is exactly doing the same thing. I'm taking my numbers and I'm writing them in expanded notation, but I'm using whole numbers with fractions, where the denominators are either tenths or hundredths. They're not halves or thirds or fourths or eighths. They are tenths or hundredths. So 43 and 65/100 can be written as 40 plus 3 plus 60, 6/10 plus 5/100, which if I take it from the fraction notation back to the decimal notation, I would get 40 plus 3 plus 6/10 plus 5/100, which would give me 43 and 65/100. And again, the students have to get used to reading that decimal point as and. 43 and 65/100. Basically what it's saying, I'm adding 43 to 65/100. So again, if we went to 21 and 90/100, that could be 20 plus 1 plus 9/10 plus 0/100, or I can write it as 20 plus 1 plus 0/10 plus 90/100. So there are different ways of getting the students to recognize or to understand that 90/100 would be the same as 9/10. Again, looking at how we can write this, and again, it's 3 different notations. It's the expanded notation using fractions, it's the expanded notation using decimals, and it goes back to taking it from the 43 and 65/100 in fraction notation to 43 and 65/100 in decimal notation. So if we want to look at what the solution would be, here's your solution, and as I stated, it's 20 plus 1 plus 9/10 plus 0/100. I have 0/100. So again, it's getting them used to that 90/100 is 9/10, 90/100. Whichever the student writes would be basically equivalent. It's equivalent. So another one of the standards is use decimal notation for fractions with denominators 10 or 100 to rewrite as 62 hundredths, as 62 over 100, describe a length of 6,200 meters, and locate this on a number line. So again, it's going back to the visual. We talked about putting fractions on a number line in a previous one. So you're looking at how do I, again, extend my number system from whole numbers on a number line to fractions on a number line to now decimals on a number line. So again, our Common Core is saying, can we put these numbers on a number line? Because all of our numbers, remember, our number line, as we extend it, has infinitely real numbers on it. So again, it's getting students to understand that on our number line are all different types of numbers: whole numbers, fractions, and decimals. So if we look at something like that, here would be, take the number 36 hundredths, which is equivalent to 36 over 100, can be rewritten as 3 tenths plus 60 hundredths. So if we look at our number line, and this is a number line that has been broken down into tenths. So if we look at, we mark 3 tenths on our number line. Between 3 tenths and 4 tenths, if I subdivide that, I'm breaking it down into hundredths. So now I would have 3 tenths and 6 hundredths. So there would be my number on a number line. That 36 hundredths would be between 3 tenths and 4 tenths. So it's again getting students to understand that between 3 tenths and 4 tenths, if I subdivide it into smaller even intervals, I now have hundredths. So again, it's representing our numbers on a number line. And I can do the same thing if you wanted to now take 362 thousandths and write that in expanded notation, and again subdivide again, and then we would basically have our numbers on the number line. So it's getting students to visualize where these numbers lie on a number line, writing them in expanded notation, subdividing between 0 and 1 into tenths, then subdividing 3 tenths and 4 tenths in the interval there into hundredths, and being able to rewrite our numbers on a number line. So here would be our number lines, breaking it down into tenths, and then in between 0 and 1/10, breaking it down into hundredths, between 1/10 and 2/10, again breaking it down into hundredths. This is a more expanded number line. So again, it's getting our students to understand that we can represent numbers just as we can represent whole numbers on a number line, fractions on a number line, we can represent decimals on a number line. So it's just taking our knowledge and expanding it to the next level. So here would be a task, and if we did this on a number line, we can say, here which is greater, which is less than, which is equal. 51 hundredths is greater than, less than, or equal to 49 hundredths. So writing it on a number line or changing it to a fraction, 51 over 100, 49 over 100, and comparing them. So looking at 51 hundredths would be greater than 49 hundredths. Now look at the second one, 4 and 5 tenths and 4 and 50 hundredths. Is it greater, less than, or equal to? So as we did before, we showed that when we expanded it, 90 hundredths was the same as 9 tenths. So 50 hundredths would be the same as 5 tenths. So 4/5 and 4 and 50 hundredths, they're equal. Here, if we look at 1/10 and 1/100th, this is the one I always tell my students I'd love to do business with them when they change 5 hundredths to 50% instead of 5%. Which is greater, which is less, that 0 has meaning. That 0 has meaning. So 1/10 would be greater than 1/100th. So again, it's going back to putting it on a number line, changing it to a fraction. So looking at how we get our students to realize that just as we can compare whole numbers, just as we compare fractions, we can compare decimals. And again, it goes to the place value, the position of the numbers. Okay. Another standard for grade 4 is compare two decimals, hundredths, by reasoning about their size, recognizing comparison, which is something we just did. Again, using visual models, using number lines, using models to compare the fractions as we just did with looking at greater than or equal to. So again, we're just looking at this as what our standards are asking us to do in being able to extend our number system into the decimal notation. So again, this is that activity I showed you before, where if I take my fractions and I start to graph them and draw the number lines, I can now compare my fractions by looking at this as a way of being able to show which is greater, which is less. So this would just be another way of using this activity by changing them to fractions and being able to graph them, showing equivalent fractions and my percent and decimal line. Okay, now into grade 5. Into grade 5, recognize that a multiple digit number, a digit in one place represents 10 times as much as it represents in the place it's right of 1/10 and what it represents in the place it is to the left. And again, these are kind of related in that it states, explain patterns in numbers, zeros of products when multiplying the numbers by powers of 10. And that's an important part, I think, when we start to get students to understand that if I take, 5/10 and multiply it, numerator and denominator, by 10, I'm going to get 50 over 100. If I take the numerator and denominator again and multiply by 10, a form of 1, I'm going to get 500 over 1,000. So again, that as my numbers increase, they're decreasing in the bottom by powers of 10s, 10, hundreds, thousands, and if they're all multiplies by powers of 10. And again, using whole number exponents to denote the powers of 10. 10 to the first, 10 to the second would be my units. My 10 to the second would be my hundredths, 10 to the third would be my thousands, and now what happens on the other side of the number line. So again, it's talking about, as I said in that definition at the beginning, that the decimal point starts to change direction of our exponents to the right. They start to decrease by -1, -2. To the left, it's 10 to the 0, 10 to the first, 10 to the third, and so on. They're increasing, and on the left, they are decreasing. And again, it's about reading and writing decimals, and I think that's an important part. When we said before, how do we take the language part of this? Looking at being able to read and write decimals. How do we write the decimals? How do we stress or state the decimal? 347 and 392 thousandths. That's, how do we write that? 3 times 100, 4 times 10, plus 7 times 1, plus 3 times 1/10, plus 9 times 100, plus 2 times 1,000. Being able to, as I said before, take these numbers and write them in expanded notation. We take our whole numbers and write them in expanded notation. Now we're taking our decimals and writing them in expanded notation. So again, we're just building upon our number system, and we're extending it from our whole numbers now to our decimals. Comparing two decimals to thousands based on the meanings of the digits in each place. Greater than, less than. Again, it's the comparison. How do we compare numbers? We do that with whole numbers. How do we now extend this to our decimals? So here is a problem that I took this problem right out of the Common Core. This was from the Common Core. This problem was on the practice test. So it says, which of these two are equivalent? 83 and 41 thousandths. 83 and 41 thousandths. So they're asking you here, they're asking you to select two answers that are correct. And if you notice, we have words and we have symbols. So again, it's being able to read the words, write the symbols. So the first one is 83 and 41 tenths. If we can read that number in the beginning where it says 83 and 41 thousandths, we would know that that one is not correct. We have 8 times 10, which is 80, 3 times 1, which is 3, 4 times 10, which is 4 tenths, and 1 times 1,000, which would be 1 times 100, which is 100. So we would have 83 and 41 hundredths. No, that's not going to be correct. We have 83 and 41 hundredths. Again, if we read the problem first, it says 41 thousandths. So D is correct because we have 8 times 10. No, I must have typed that wrong. I typed that wrong. Okay. So D should have been the correct answer. Where I typed it when I typed it, I apologize. That should be 8 times 10, 3 times 1. I left out the 3. 4 times 100, 1 100th, and 1 times 1 1,000, which should have given me 83 and 41 thousandths. You don't know how many times I've gone over this PowerPoint and I didn't pick it up till now. There you go. So D and E would be the correct answers. D, because my mistake should have been 3 times 1. I left the 3 times 1 out. And 83 and 41 thousand. So D would be the correct symbolically, and E would be correct in the verbal, in the words. So my mistake there. Again, select two comparisons that are correct. 83 tenths and 3 and 78 hundredths. 5 and 69 thousandths is less than 5 and 69 hundredths. So again, looking at what we have here, 5 and 69 thousandths and is less than 5 and 69 hundredths. What could we say there? That's not less. It's actually equal. They're equal because I can take 69 thousandths and change it to 6,900. So that's kind of a tricky question. This also came from the PARCC, although I know PARCC has been kind of put on hold a little bit. These are the type of questions, but if we look at the standards, these questions are getting kind of to the standards and things that we should get to, not even based on that. The students should know the written word and the symbolic. They should know the symbolism and the written word. I think that's important, and that's what we said when we looked at our model. The language, the connection between it with the kinesthetic, with your manipulatives, being able to use your base 10 blocks, being able to write it into words. So that's all an important piece here. So if we look at this, you know, we have 60 plus 25 hundredths plus 8 thousandths. So that would give me 60 plus 258 thousandths. That's not greater than 60 and 342 thousandths. So again, being able to take the expanded notation and change it back to the simplified notation and being able to make the comparisons. So I think it's that conversion piece that we did with our whole numbers is just an expansion here and being able to do this. So it's looking at these problems in different ways, not just the symbolic, but also the written word and being able to make those comparisons, knowing the place value, what we have in our place value, being able to make those comparisons. using place value to understand to round decimals to any place. That's an important piece because rounding becomes an important part of how do we look. We have to look to the number to the right to be able to round either up one or drop it. So being able to understand when we look to the right how we looking at our place values. If we round to tenths, we look to hundredths. We want to round to hundredths, we look to the thousands. So being able to look at rounding the decimals to any place, understanding when we talk about the place value, looking at the place value of a number. So we want to look at now how to add, subtract, multiply, and divide our numbers. So we're looking at the relationships, and again, we're expanding our numbers and how we add whole numbers, how we add fractions, and how we add and subtract and multiply and divide decimals. Adding and subtracting decimals becomes, I think, a really difficult operation for students because we teach students to line numbers up from the left to the right. Our students tend to disregard the decimal point and just line the numbers up to add. So this becomes an intriguing I think, concept to teach them, that we line up the decimal points and we line up our numbers going to the left and to the right of the decimal point, and being able to explain the reasoning why, because we add tenths to tenths, hundredths to hundredths, whole numbers to whole numbers, ones, units to units, tens to tens, and that becomes an important part, and it goes back to knowing place value, and I think that's an important part. And again, as it states, using concrete models and drawings, again, using our base 10 blocks, being able to write these symbols down. And I think we're going to show you 2 videos right now for addition.
One of in each video, what we're going to be doing is we're going to be showing you how the addition can be done by almost in a sense disregarding the decimal point, and really talking about what Maria has consistently talked about has been the place value as an analogous situation, the decimal place values being analogous to the whole number place values. So what we've tried to do here is develop the operations as if you could actually take out the words ones and tenths and put in the words tens and ones and basically have the same thing happening. And that's what you really have to do in showing your students, that it is not something new. It is just the same operations with place value that they've done with tens and ones. However, now we're doing it with other things called ones and tenths.
We're going to discuss how to add 2 numbers, which include both whole numbers and decimals. So we're going to look at 2 and 5/10. So there we have 2 and 5/10. And to that, we're going to add 1 and 7/10. So let's record that. We're going to add 2 and 5/10. Okay, so 2 and 5/10. And to that, we're going to add 1 and 7/10. So let us start with the tenths. We're going to add our tenths. When we put our tenths together, we have 12 tenths, which is a lot of tenths. So what we're going to do is we're going to cut down on the number of tenths by trading 10 of our tens for 1, 1. So we're going to take 10 of our tenths and trade them for 1, 1. So there's 10 of our tenths being traded for a new 1. So let's record that. We now have 2 tenths left over. And since it's in tenths, we bring down the period or the decimal point to show that this is 2 tenths. And we take our new 1 and we put it up here. And these are the tenths that we traded in. So let's record that. We traded in 10 of our tenths for a new 1. Now let's add the 1s. We add the 1s from the original problem first. We have 2 1s and 1 1 give us 3 1s. And then we have the 1 from the new problem, which gives us 4 1s. So let's record that. So when we add 2 and 5 tenths and 1 and 7 tenths, our answer is 4 and 2 tenths. And the reason for that is we traded 10 of our tenths for a new 1.
Let's go to the slides. Okay. Now, something Maria stated before is something this next video addresses, is not so much, adding very nice tenths and 1s and 1s, but what happens when you have mixed numbers. Not mixed numbers in the sense of mathematics, but where you have tenths and hundredths in one and you only have tenths in the other. And then she went on to say that the kids just write them out straight across as if they're adding 3-digit numbers. If they're all 3 numerals, they'll add as 3-digit numbers, almost in a sense not paying attention to the decimals. So here is a way of hopefully they could pay attention to the decimals, and it's just a very simple process.
I just wanted to say before we go on too, in the last video you saw that we took the 10 tenths and we converted it to a 1. That goes back to, again, using our base 10 blocks in how we take 10 ones and we make it 1 10. So again, it's that regrouping, and you're getting them to realize that our number system is based on constantly regrouping or trading in. So it's just an extension of what we did with whole numbers, we're now doing with decimals. So again, it's just a pattern that they get used to seeing. It's this extension of our number system. So here's this video again.
Let's look at another type of addition of decimals, where there's more than one number and the decimals are somewhat different. Let's start with adding 3 and 47 hundredths, and to that we want to add 13 and 3 tenths and 46 hundredths. Now it is important that we put the 0 there to show that there are no whole numbers involved. We don't have any whole numbers, and also in technical writing, that's the proper way to do it. Now the question is, how do we set this up in a vertical form? One of the things we did, and I want to give a thanks to Jim Chalakis and Jack Lutz from East Brunswick for giving me this idea. The first thing we're going to do is we're going to write the whole numbers in vertical form. So we're going to write 3, we're going to write 13, and we're going to write the 0. Those are the whole numbers from our 3 decimal numbers that we're trying to add. Now what we're going to do is we're going to go back and complete each of the numbers. So I'm going to have 3 and 47 hundredths. I'm going to have 13 and 3 tenths. And I'm going to have 46 hundredths. And now I'm going to add. Well, I'm going to start with the hundredths. Since I don't have any hundredths in 13 and 3 tenths, I can put a 0 here, or I can leave that space blank. It doesn't matter. So now I'm going to add the hundredths. I have 7 hundredths and 7 hundredths and 6 hundredths gives me 13 hundredths. So I can take 3 of my hundredths and leave them here. I can trade in 10 of my hundredths for a new tenth. Now I add my tenths. I have 4 tenths, and 3 tenths is 7 tenths, and 4 tenths is 11 tenths, and 1 tenth, the new tenth, is 12 tenths. Again, as we did before, I leave 2 of the tenths here, and I trade in 10 of the tenths for a new 1. And I put my decimal point to show that my work with my decimals is over. I am now going to work with my whole numbers. I add my original numbers first, the numbers from the original problem. I have 3 1s, and 3 1s gives me 6 1s, and 1 more 1 gives me 7 1s. Now I go to my tens column. I have 1 10 in the tens column. So when I'm adding 3 and 47 hundredths plus 13 and 3 tenths plus 46 hundredths, the first thing I do is I line up vertically my whole numbers, 3, 13, and 0. Then I fill in or complete each of the whole numbers, 3 and 47 hundredths, 13 and 3 tenths, and 46 hundredths, and then I add, trading as is needed as I go through my addition.
As we saw in the last video, again, it's getting the students to, again, go from the manipulatives to mentally stating that now I'm going to trade. I'm trading my tenths to give me a whole number. I'm trading my hundredths to give me a tenth. So, again, it's that working with, and we saw in the Lesch model, the manipulatives, the being able to, go to solving the problems, drawing pictures, drawing diagrams. So, and as we stated, it's going from the language, the kinesthetics, the language, to the symbols. So again, it's all coming together, starting and expanding it. And again, it's getting them to understand now mentally how I can go from using my manipulatives or my visuals to doing the problem symbolically. And I think that's an important part of what we're trying to get the students to realize, that it's an extension of, again, our number system. And in grade 5, they talk about being able to multiply and divide decimals. So again, we're going to illustrate how we're going to do a video with being able to multiply the standard algorithm of multiplication and division.
Okay. In this multiplication video, what I want you to pay notice to is, again, we've been talking about using items from mathematics that children have from their background with whole numbers. I want you to notice that in this case, we use a vertical model for multiplication. We do not show the changing of one of the numbers to a mixed number and another number to an improper fraction and another one to an improper fraction, and doing all that. We go directly from what they know about multiplying whole numbers vertically to multiplying decimals vertically.
Let's talk about multiplication of a decimal numeral by a whole number. So let's look at the number 2 and 6 tenths. And let's record that. So we have 2 and 6 tenths. And what we want to do is we want to multiply 2 and 6 tenths by 2. Now, what does that mean in terms of these things? It means that we want to have 2 sets of 2 and 6 tenths. So let's make another set of 2 and 6 tenths, because that's what it means to multiply. We're going to have 2 sets of our number. And to show that, I'm going to write that in red. So the 2 and 6 tenths is shown here. The fact that we have 2 sets of 2 and 6 tenths, I'm showing by writing the numeral 2 in red. when I'm recording it. Now let's do our work. Well, the first thing we're going to do is work with the tenths. We have two sets of 6/10. We have two sets of 6/10. We put them together. Again, what we can do is, since we have so many tenths, we can trade 10 of our tenths for a new 1. So let's do that. So we're trading 10 of our tenths for a new 1. And that means that we have 2 tenths left over. So let's record our 2 tenths that we have left. And let's put the decimal point to make ourselves remember that it's 2 tenths that are left. Now we've traded 10 of our tenths for a new 1. So we put the new 1 up here and we take our 10 tenths off. And let's record the fact that we have a new 1. Now, let's put the old ones together first. From our original problem, we have 2 1s twice. So we have 2 1s twice. So 2 1s twice is 4 1s. And then we have the new 1, which makes 5 1s. So let's record that. So in multiplying 2 6/10 times 2, we are really dealing with 2 sets of 2 6/10. And so our answer is 5 2/10, because what we can do is we can trade 10 of our tenths for a new 1.
And finally, the last video deals with, if you will, the dancing decimal point. In other words, why when you divide by a decimal, you move the decimal place? Why can you do that? And at the beginning, what we're doing here is giving you a way of, at the beginning of this type of teaching this concept, to show the students how patterns play an important part in mathematics and how patterns can really get them to understand this somewhat complex concept of dividing a decimal by a decimal.
We're going to talk about dividing a decimal by a decimal. In this case, we're going to talk about dividing a number of tenths by another number of tenths. So let's start with looking at a pattern in mathematics. We know that 6 divided by 2 gives us 3. Interestingly enough, 60 divided by 20 also gives us 3. And when you look at it, you can see that the 6 and the 2 here are in the ones place. And so when I divide 6 by 2, I get 3. Here, the 6 and the 2 are in the tens place. So when I divide 6 tens by 2 tens, I get 3. Let's look at another example. 600 divided by 200. Since the 6 and the 2 are in the hundreds place, I can say that 6 hundredths divided by 2 hundredths will give me 3. So anytime you have 2 numbers in the same place and you're dividing, the answer will always be the same. So I have 6 and 2 dividing here. They're in the ones place. My answer is 3. 6 in the tens place, 2 in the tens place. 60 divided by 20 is 3. 6 in the hundreds place, 2 in the hundreds place. 600 divided by 200 is 3. Now let's look at 6 tenths divided by 2 tenths. The 6 and the 2 are in exactly the same place. They are in the tenths place. So because of the mathematical pattern involved, 6 tenths divided by 2 tenths is going to be 3. And so now you see where that rule about moving the decimal place comes from. I can have 6 tenths divided by 2 tenths, and that's going to be the same as 6 divided by 2. So in a sense, instead of trying to work with 6 tenths divided by 2 tenths, I can use this pattern, change this problem to 6 divided by 2, and still get an answer for 3. So therefore, 6 tenths divided by 2 tenths is 3, because that's the pattern that forms in mathematics when the numerals are in the same decimal place.
Okay. Are there any questions, comments? We hope that what we did was to be able to show you how to work with decimals by expanding them, using them on a number line, a way of being able to add, multiply, or divide fractions, decimals, being able to write a decimal as a fraction, go from fraction notation to decimal notation to fraction notation. So that decimal point is important, but because it separates the whole numbers from the fractional part, the fractional part is a little bit different. Being able to extend our number system into fractions, from fractions to decimals, using a number line, using the base tens. So I'm hoping that we gave you something to think about. Our time is up. It is 5 o'clock. So if you have any questions or comments, please type them in. We would be glad to answer them. If you have any questions or comments, I'll put up our emails for my email and Frank Gardella's email. You can email us with any questions or comments. We'd be glad to hear from you. So are there any questions or comments? How did you? I created that graph paper.
Read the question.
It says, I teach 8th grade. I'd like to know how to get the graph paper. You had to show slope. I created it. If you send me your email address, I can give you the template that I used. Just email me, and I will gladly, send it to you. Sure. Send me your email, and I will get you a copy of the problems that were solved. I will definitely do that. Just send me, send me an email, and I will definitely send them to you. Any other questions or comments? Yes, I believe you'll get that from Barbara. You'll get a certificate for participation. I believe that the director at Ryder will send you that. Definitely. Okay. Let me get you this.